Hello and welcome back to algebra. So I'd like you really quickly to think about the last time that you used a ruler. It might have been many, many years ago, but you probably measured to the nearest inch, half inch, or centimeter. But you're human, and no measurement is exact. You always measure to the nearest something. So anytime as humans that we make a measurement, there's always a certain amount of possible error in our measurement. So we're going to look at how to find the greatest possible error in any measurement. So this is a term that we need to know, and you need to write down this definition. The greatest possible error for any measurement is always exactly 1/2 of whatever unit is used to measure. All right, make sure you have this down. The greatest possible error for any measurement is always 1/2 of whatever unit is used to measure. Let's look at a couple of real-life examples to clarify this. Let's say that I'm in the kitchen and I'm making a recipe, and my recipe is, it calls for about 4 grams. I want 4 grams of cherry juice. So I get out my kitchen scale and I weigh my cherries, and my scale tells me that I have 3.8 grams of cherries. Well, it's pretty close to 4 grams. Would this work? Well, let's think about what my closest possible error could be in this measurement. Based on my definition for greatest possible error, it's half of whatever unit is used to measure. So the unit that I'm measuring with is my grams, right? So the greatest possible error is going to have to be half of a gram. That's it. That's all you do. So the greatest possible error I have in my measurement of 3.8 grams is plus or minus half a gram. So my actual weight could be 3.8 plus 0.5 grams, or it could be 3.8 minus 0.5 grams. So if I'm wanting to find the range of possible actual weight, I need to take what my scale read, the weight given, and then I have to add or subtract the amount of possible error. All right, let's look at another scenario just to review this idea. Let's suggest that maybe you were measuring a picture for the yearbook, or a picture that was in the yearbook, and you record that this picture is 9 centimeters high. Well, if this is you, you might not have much longer on this earth. But your picture is 9 centimeters tall, and I ask you to find the greatest possible error with this measurement. So again, my greatest possible error for any measurement is always 1/2 of whatever unit is used. So what's my unit? Well, my unit is my centimeters. So half of that unit would simply be half of a centimeter. I could express this as a decimal in 0.5 centimeters, and that's probably going to be your easiest method of expression, is your decimal form. All right, but then let's say that I ask you to find the range of actual measurements. How tall could this picture actually be without human error? Well, I start with my original, which is my 9 centimeters. And then I want to add the greatest possible error that I could possibly have. So I'm adding this 0.5. So 9, whoopsies, let's do it with a pen. 9 plus 0.5 is going to give me 9.5 centimeters as 1. All right, but then to find the range, I have to have the greatest. I've got to add this, and I'm also going to have to subtract. So I'm going to go back to my original, which was my 9 centimeters. And this time, I'm going to end up subtracting my 0.5, which is going to give me 8.5 centimeters. So if I want to find the range of actual physical measurements without human error, it would be between 8.5 and 9.5 centimeters. Telling me that I could be off by half a centimeter in either direction. It might be half a centimeter shorter or half a centimeter longer, depending on my human error. So again, to find the greatest possible error, you take half of whatever unit you have. And if I ask you to find the range of actual measurements, you're going to have to add the greatest possible error to your original, and then you have to subtract the greatest possible error from your original. All right, I'd like you to do one exactly like this on your own. All right, let's do a scenario like this. You're at the grocery store and you pick up a package that weighs 16 ounces of strawberries. Well, I want you to find the greatest possible error within this package, and I want you to find the range that this amount of strawberries could actually weigh. You might have a little bit more than 16 ounces, and you might have a little bit less than 16 ounces. After all, they're packaged and weighed by humans. Go ahead and complete these on your own, and we'll check your answer tomorrow in class. Let's look at finding the percent of error now. Let's say that I am thinking back on this picture that I measured for the yearbook, or from my yearbook, and I know what my greatest possible error is, and I know what the range of actual measurements on this picture could be, but now I want to know what the percent of error actually is. Well, my percent of error is going to be my greatest possible error over the initial measurement. So if I go back to my picture example, I discovered that my greatest possible error was that 0.1 centimeter. It's half of the unit used. So I'm going to write, again, this is most helpful in decimal form. I'm going to write 0.5 centimeters, and I have to divide it by my initial measurement, which was 9 centimeters. And recognize that you're finding a percent. Do the math, plug it into your calculator. What do you got? Hopefully you got something like 0.05555555. Go on and on. We're just going to end up rounding this to about the nearest hundredth. So it's about 0.055, okay? Now, again, I'm taking a percent, so I've got to multiply it by 100. Your percent of error is always this answer, but multiplied by 100. All right, so in order to do that, this becomes 5.5. My decimal just moves 2 places, and it's 5.5%. It's not a huge percent, but I want you to see what happens if I measured my picture originally as, instead of 9 centimeters, let's say I measured it as 9.0 centimeters. If my initial measurement was 9.0 centimeters, what is my greatest possible error? Well, it equals half of 1/10 of a centimeter. And here's why. I measured to the nearest tenth. This is the same as 1/10, yes? I really hope so. So if I'm taking half of my unit, I'm taking half of 1/10 of a centimeter. That's also the same as 0.5 times 0.1 centimeters, which, if you plug that into your calculator, is going to give you 0.05 centimeters as my greatest possible error. So what percent of error is this greatest possible error? Well, using my formula, I'm going to plug 0.05 because that's my greatest possible error. I'm going to divide that by my initial measurement, which was 9.0. And remember that you're always multiplying this by 100. Plug it into your calculator. What do you get? Hopefully you got something that looks like mine. So again, I'm multiplying it by 100. So I'm going to have to move this decimal 2 places, and it gives me a 0.55% of error. That's a really small, it's half of a percent of error. All right, so hopefully you can see how you can find percent of error from greatest possible error. At this point, I'd like you to go back to that strawberry example you worked where you found the greatest possible error and the range of actual measurements. I'd like you to look at that 16 ounces of strawberries that you had, and I'd like you to find the percent of error using the greatest possible error that you found. What is the percent of error with this container of strawberries? Write it down, show me your work. You might want to rewind and watch how I did percent of error, and I will check it tomorrow in class. Let's look at one more concept you need to know. Let's say that you're measuring a room. You want to carpet this room, or you want to rip up carpet and put down hardwood floors, and you need to know the area of your room. So you measure and you draw a little diagram, and you decide that your room measures, about 7 feet by 13 feet. It's a decent sized room. All right, so both of these measurements were made to the nearest whole foot. So I want to find what the greatest possible error is first. And then I want to use the greatest possible area to find the maximum and the minimum possible area. So here's how this is going to work. There's a couple of steps. The first thing I want to do is find the greatest possible error. Make sure you're writing down these steps, by the way. So my greatest possible error when I'm looking at this room is going to be what? Well, my greatest possible error for any measurement is always half of whatever unit is used to measure. My unit is what? Well, it's in feet. And to make things easy for us, it's in whole feet, not even in tenths of a foot. So I want to find what is 1/2 of 1 foot. Well, that's pretty easy. That's just 0.5 feet. Fortunately, that part was easy. Now I have to move on to step number 2. Now that I have my greatest possible error, I'm going to end up having to find the maximum area. So let's look at how to find that. Well, if I'm wanting to find the maximum possible area, then it means that I need to find the greatest possible error and add it to my measurements. So if I'm looking at this 7-foot width that I've got over here, it could be that if I'm off by half a foot, that it's 7 feet plus 0.5 feet, which is what? Well, hopefully you got 7.5 feet. Okay, well, I have to do it to the other measurement too. So let's say that I have 13 feet, and it could be as big as actually 13 plus half a foot, which hopefully you recognize as 13.5 or 13.5 feet. Okay, once I've added the greatest possible error to both of my measurements, the next thing that I end up having to do here is to find my area. So I'm going to take the greatest possible lengths that I've got, and area is length times width, right? Well, I'm going to use 7.5 as my new length and 13.5 as my new width, or vice versa if you think of it in reverse. So do your multiplication, and how many square feet do I have? And hopefully your calculator was like mine and gave you 26.25, and because it's area, it's feet squared. All right, why does this matter? Well, if I think about this room, if I were to take the original area here and just multiply based on my measurements and then order the carpet, how many square feet of carpet would I get? Well, I'd get 7 times 13. And what is that? And I would end up with something like 91 square feet of carpet. But if my measurements were off by a few inches, what happens if I actually needed more? And I just realized my calculator wasn't plugged in right and did not give the answer that you probably had. So I just crossed it out. I don't feel like going back and re-recording the whole thing. So hopefully with your purple area here, you got 101.25. Let's compare that with this 91 that I've got here. If I believe that this is 91 feet squared, and I'm so confident in my measurements that I order 91 square feet of carpet, but it turns out I'm a little bit off in my measurements and the room was actually just slightly barely bigger than I measured, I could end up short a few square feet of carpeting. So I end up with carpet I actually needed carpet like out to here instead. And so maybe the carpet doesn't end up meeting my baseboards. Ruh-roh, we've got a problem. Okay, so now what happens if I wanted to find the minimum possible area? It's going to be almost exactly like finding the maximum possible area, just in reverse. Notice I added the greatest possible error to my measurements to get maximum. Add greatest to your measurements to find maximum, and then find your area using these. It's in reverse. What do you think we're going to do? Well, hopefully you said instead of adding, you're going to subtract the greatest possible error from your original measurements. So again, I'm going to start with my 7 feet, my width here, and my 7 feet minus my 0.5, which I got from up here. And that, hopefully, when you plug it in, is going to give you 6.5 feet. My room might be a little bit smaller than I needed. Or perhaps it's I'm going to need to look at my next measurement in 13 feet. Again, subtract your GPE, subtract your 0.5, and that would give you 12.5 feet. So just like before, the next step here is I've got to actually find this area using my new measurements. So my new area is, again, length times width. Formula doesn't change. So let's do 6.5 times 12.5. And make sure you take care to actually put it into your calculator correctly, like I didn't last time. What do you get? Hopefully you got 81.25 square feet. If I'm wrong, shoot me a message on Classroom, and I apologize. So again, if I go up to my diagram, it means that my room was just slightly off, and it's a little bit smaller than what I need. And this green area gives you an idea of the range at which my room could be based on the measurement that I had. So I end up with a couple of ranges for my area. So if I ask you for that, the minimum area is 81.25 and the maximum is 101.25. All right, good to know if you plan on remodeling. All right, your turn. Let's say that your mom painted your room baby pink when you were born, or if you're a boy, maybe baby blue. And you've grown up since then, and you want to repaint your room. And she's given you the go-ahead, she's given you a budget. But in order to paint your room, before you can do it, you need to know what your area for your wall is, so you know how many square feet of wall you're covering. Okay, so you measure, and you decide that your wall is 8 feet by 12 feet. Well, we want to make sure we get enough paint, so we need to find the minimum as well as the maximum area for our wall. Go back through, do the exact same steps that I did over here when I was looking at my floor plan, and find your minimum and maximum areas using your greatest possible error. Bravo, well done. I will see you in class later.